Hi everybody. Today tutorial session will be polynomial. Polynomial is really very important in many application, physics and engineering. So let's just look at this polynomial. P of x is equal x squared plus x minus x. So this polynomial of order 2, and the independent variable is x, and the value of the polynomial will be saved in P of x. So the first thing, how can we represent any polynomial? Polynomials are represented as a vector, a row vector, and we use the coefficient of the polynomial, and it should be ordered, the highest first till you go to the constant term. In this case, the coefficient of x squared is equal 1, coefficient of x is equal 1, and the constant term is equal -6. So in this case, we can write just p. We don't write p of x, p equal square bracket, and then the first coefficient is 1, the second is 1, and the constant term is -6. So that will be the representation of a polynomial. If you hit enter, then you get the 1, 1, -6, which is the coefficient of the polynomial. What happens if there is one term is missing? Like what? Let me just write another polynomial here. Let me make a copy of this one and have another one. And let's say that's order 3. Its coefficient is 5. And now we have a polynomial of order 3. So how you represent it? Let's just call this one B2, for example. So you write P2 is equal square bracket. The first coefficient will be equal to 5. The second should be x squared, but x squared is missing. So if you want to be precise, you can rewrite this polynomial by adding the x squared term, which will be of coefficient 0. So, okay. I'm sorry, it should be the other one. That's x power 2 plus. So in this case, when you are missing something, you can consider 0 coefficient. So write 5 and then 0, that's the coefficient of x squared, then 1, which is the coefficient of x, and then the constant term -6, and leave space between each term. So that would be the representation for polynomial B2. Okay, so that's easy. What's next? Well, we have two important applications for polynomial. To find the value of polynomial and to find the root of polynomial. Let's first find the value of a polynomial. Polynomial P, the first one we have at x squared plus x -6. We still save it here. That's P 1, 1, -6. If we want to find the value of this polynomial at x equal 4, so manually we are going to substitute by x equal 4 in every term. So x squared will be 4 squared plus 4 minus 6. 4 squared plus 4 minus 6, you get 14. So how can you do that using MATLAB? Let's say it's the value, it will make it equal to y, and say y equal to the we write polyval. Polyval means the value of the polynomial. That's the way you write it using MATLAB. And then since it's a function, then you have square here. Once you hit polyval and it's a function, then you get this list from MATLAB to help you. I'm just going to write 4. So MATLAB will understand that I want to find, but now MATLAB will ask polynomial, what polynomial? You have now two polynomial, p and p2. Okay, I'm going to evaluate the first one, which is p. So now polynomial p and x is equal 4. And they'll give you the value, which is equal 14 as well here. That's 14. Well, sometimes you can write x is equal 4. You define x, and now you want to find the y, which is the value of the polynomial. Say polyval. The polynomial is p and x, because already x is defined equal 4. So it will replace x by 4. And you get the same number. So that's the way you do it. If you have the number, you can plug it in after you write p. Or if x is already defined equal 4, so you can write x and MATLAB will understand x is equal 4. That's helpful, especially if x is like a vector and has many values, so you can do it in one shot, and I'm going to show you an example like that. Let me just do it now. Let's say that x varies from -5 or from -2 to 2. So you can write x is equal from -2 up to 2. If you write it like that, we explained last time, it means the default is 1. It's going to add 1 every time. So you have -2, -1, 0, 1, 2. Let's see. So these are the value of x. So let's say that the polynomial p, we need to find its values at every single value of the vector x. So you write y equal polyval, the polynomial p, x, and now x is a vector, so we expect we have many values. Let's just hit it. Okay, so what does it mean? The polynomial is equal -4 when x equal -2, equal -6 when x equal -1, and so on. So you have 6 values of x, you have 6 values of the polynomial. All right. Should you write y equal? No, not necessarily. If you just write polyval px, it will just get the values. Oh, there's missing, see, it has to be balanced brackets. So you get the same thing. But I just want to store the values of the polynomial in a vector y, because sometimes you want to perform another operation on the result. So I call it y. All right. Now let's go to the root application. How to find the root? What does it mean, the root? We'll go back again to if you want to find the roots of this equation, it means you want to then find the value of x that it will make the polynomial equal to 0. So just simply say, if you want to solve this question, when the polynomial equals 0. Solving equation in general, yeah. So you use roots. So let's just write, for example, r equal, I'm just doing r, any variable name I choose, 0, no, not 0, I'm sorry, root of the polynomial p, which is, p is defined here as x squared plus x minus 6. Okay, let's just hit enter. So you got the two roots, -3 and 2. What does it mean? It means when x equal -3, or x equal 2, the polynomial value will be equal to 0. I said, okay, that's interesting. Let's just check if this is true or not by using the polyval, right? It'll give you the value. So let's just write polyval of the polynomial p at, let's set x equal -3, 0. And if you want also the other root, which is equal to 2, 0. So that's how we find the roots of a polynomial, using the function roots. Great. Now let's just, we want to write a MATLAB program to plot a polynomial, x squared plus x minus 6. We want to plot over the domain from -5 to 5. So let's go ahead and write the program. So I already prepared the program here. That's a polynomial. We're going to plot a polynomial. We use the same command here, CLC, clear, to make sure that the memory is clear and clean. And then we'll start to define the domain. The domain, it's from -5 to 5. So how we'll do that? Well, you define x equal -5 up to 5. But if you are going to plot and you are doing that, the increment default is equal 1. It means it will plot the polynomial when x equal -5, -4, -3, -2, 1, and so on. So only increment by 1, which will make the polynomial does not look a smooth curve. Let me do that and see how can we fix this. So that's the domain, x from -5 to 5. You have to define the polynomial. You define the polynomial by the coefficient. And the polynomial is, I remind you, x squared plus x minus 6. So you have 1, 1, -6. All right. Semicolon. We define the polynomial. Next, I want to make the plot. How you do the plot? Well, first you want to find the value. So say y is equal to the polyval, because you want to find the corresponding value for x's. So you say polyval, as we did before, px. So this y will give you the corresponding values of p for every single value of x. Great. Now you have two rows, equal elements. You can plot it by plotting y against x by using plot command. So plot and see x, y. Well, I'd like to have the line width equal to 2 to make it clear. All right. Now that will make, I like to have also the grid. So grid on. I'm not going to go through the details of plotting commands that we did last time, how to add the title or x label, y label. We did that last time. So let's just do and find that. To O, since you have going to have a figure, so you don't forget to add SLF, clear figure. And what else is supposed to do? You're supposed to save this file. It will not run if you didn't save it. So just will go for File, Save As, and just you have to go to the directory where you MATLAB. So MATLAB in my computer in Document, and I scroll down till I get MATLAB. Otherwise, it will not run. Here you go. That's my folder. You just call it example 4, for example. And just name, save. Now I can run the program. All right. So if you didn't get anything here, it means your program is right. And you search for the figure. Here you go. That's the figure. So that's x, and that's y. And you observe it's just there is a value at -5. There is a value on 4, and then connecting straight line between each one. So if you want to make it smooth, you can just go ahead, and I advise you to do that. Make the increment is 0.01 when you have continuous function. Most of the function work with increment equal to 0.01. Now we run again, you will get a smoother curve. You see, that's more smooth. Yes, not segments, connected segment or piecewise. It's just smooth curve. So that's how we plot the polynomial. Easy. All right. So let's go next. The operation. Let's have two polynomial P1 and P2. Let's make it in command line here. Okay. It's not all right. So the first polynomial will be P1 equal x squared plus 3x plus 7. So you have the coefficient is equal to 1, 3, 7. What is the second one? The second polynomial is x, p2 equal, there was nothing here, it was x plus 1. If you have it x plus 1, just forget about 0x squared. If x plus 1 and you type 1, 1, it's the right representation for the second polynomial, but the problem is when you're going to add, you will have a problem. Let's say that the p, which is the result of adding p1 plus p2, then if I do that, you will get error. However, you represent p2 in the correct way because polynomial p2 is equal x plus 1. But when you are adding or subtracting, the number of terms of both polynomials should be equal. So if you have 3 terms here, you have to have 3 terms here. That's why I added 0x squared. So actually, if you represent the second polynomial in the right way when you are adding, so you should put 0 for x squared and then 1, 1. And now when you do the addition, it will add 1, 4, 8. Because when you are adding these two, 1 plus 0 is equal 1. That's the 1. And you are adding 3 and 1 is equal 4. That's 4. And then 7 and 1 is equal 8. It did the addition. The same way when you do subtraction, you see b1 minus b2. Again, both they should have the same number of terms. So if you are missing one, you just add 0. In this case, I was missing the first one because this is first order polynomial. And it's correct to present it by 1, 1. But when you are adding, it should be the same number, the same length. Okay? So now let's do multiplication. How you do multiplication? Well, when you are multiplying two polynomial, and I'm going to multiply the two polynomial, you still can use P2 represented in this way, no problem, all right? But you don't use multiplication, the asterisk. So see, let's say P is equal P1. If you do that, you will get error. It doesn't work with polynomial. Said, okay, let's just hit enter. I know, all right. Error, it doesn't. It doesn't, all right. So what is multiplication in polynomial? What is the function of multiplying two polynomials in MATLAB? P is equal to, you use the command conv, which means convolution. So conv, the first polynomial, which is P1, the second polynomial, which is P2. Hit enter, and you get this. Because as you see here, when you are multiplying, one polynomial is x squared. That's order 2, and this is order 1. So when you get the result 0, 1, 4, 10, 7, what's the order of this one? That's a constant term, and that's the first term, order 2, order 3, not order 4. So it'll be order 3. So when you write, the result will be x squared plus 4. Let me just make it. Oops. That's the result. And how we write the result. All right, let's just make it. Yeah, that's the one in yellow. X cubed. All right. Plus 4x squared. Why 4x squared? That's 4. That's one is a coefficient of x cubed. And this one, x squared. And this is x, 10x plus 7. 10x plus 7. So that would be the multiplication. So multiplication of polynomial, use the function conv. What about division? All right. When you divide, I'm going to show you here this one. Let me just make it bigger so you can see the screen bigger here. All right. That's the division. That's the division. When you divide the polynomial P1 by over 2, this by this, then you get, that's the output here. The result x will be x plus 2, and the remainder is equal 5. That's why you write 5 over x plus 1. So x plus 2, that's the result of the division, and 5 over whatever we are dividing by, 5 is the remainder. So, great. So, how can we do the multiplication? I'm sorry, multiplication use conv, which is convolution. Division use deconv, which means deconvolution. So write P is equal to, don't write, if you write P1 divided by P2, you get error. It doesn't work. Now let's check. Oh, it didn't do division of polynomial. It didn't. That's not the division of polynomial, because that's equal 5. You are getting only the remainder. But you want to get the whole result. You want to get the result x plus 2. The polynomial means 1, 2. You have to get 1, 2. And then the remainder you get 5. So we use the convolution. So you don't write P now. Why? Because the output of the division, two things. You are getting the result of the division and you are getting the remainder. So you are getting 2. In MATLAB, when you have two outputs, so you use the square bracket for the function. So you write Q R equal, then somebody will ask, should I write Q R? It's obligation. No, you don't have to. You can choose any two variable names. I'm just using Q and R, so to remind me, Q is the quotient of the division, R is the remainder of the division. That's all. But you can write X, Y, Z, whatever. It doesn't. Equal. This one you have to write deconv. That means it's going to divide. Divide which polynomial? P1 and P2. So MATLAB will understand you are going to divide P1 by P2, and the result will be saved or stored in Q, and the remainder of the division will be R. If there is no remainder, I'll give you R equals 0. All right. So if you do that, then hit enter. Oh, there's here error using deconv line 2.1. So what the mistake here do you think? Or I'll tell you what. When you type B1, but just remember when format, compact, so it will not leave a big space. P1, that's x squared plus 3x plus 7. P2, 0, 1, 1. You remember why we put 0? Because when you add, subtract, you have to. In multiplication, you don't have to, but subtracting, addition, you got to have the same number of terms. In division, you should not have the first term equal to 0. So what does it mean? It means you can write or express the second polynomial P2 normally. You don't have to add term and you put 0 coefficient to make them have equal elements or equal number of variables. No, 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 no. Division of polynomial does not accept 0 coefficient as the first one. Because when you divide something by 0, you get infinity. That's the reason. So what is that? What is the answer? Just express P2 normally. X plus 1. So it will be B2 equal 1, 1. That's just like that. Now, when you do the deconvolution to get the division of the two polynomial, it will accept it and it will give you the result. What is the result? 1, 2. What does it mean? It means when you divide B1 by B2, you get x plus 2. That's cute, means that the result of the division. And the remainder is 5. The remainder is 5. Then you might ask why there are 2 zeros in the head of 5. Because P1, when you remember P1, that's P1 here. See? 3 terms. That's when you put on the top when you divide. So the remainder should be the same out. That's why. So you have 0, 0, 5. The remainder is 5. So briefly, when you divide P1 by B2, you get the result 1, which means x plus 2, and the remainder is 5. That's here what you have. That's what I show you on this side. Okay. Interesting. Now, how you differentiate? If we are going to differentiate P1 and P1, it's equal x squared plus 3x plus 7. Let's just write P1 here. P1 is equal to, the coefficient will be equal to, let me just mark here this P1, make it yellow. Now we don't want this one here. So this is the P1. What I want to do, I want to find the differentiation. If you differentiate that, x squared will be equal to 2x, and 3x when differentiate will become 3, and 7 is constant, difference is equal to 0. So I expect I get 2x plus 3. So what polynomial coefficient you expect when you differentiate P1? You expect to get 2, 3. 2, 3, right? That's what we're supposed to get. All right, let's just. So how you get the differentiation? Let me first express P1, which is equal to 1, 3, 7. That's the coefficient of the polynomial. I want to find the differentiation. Let's call the differentiation y, whatever, equal. And what is the function name of differentiation of polynomial in MATLAB? What do you use? Poly, der, derivative. So poly, they are using really a simple thing. They're poly always, like polyval, poly der, derivative. All right. Then you're going to put here the name of polynomial that you want to differentiate, which is in this case is P1. So let's just look at it. You want to find the derivative of the polynomial P1. And the polynomial coefficients are 1, 3, 7, and we expect to get 2x plus 3. We expect to get 2, 3. Here you go. That's right. We got 2, 3. 2x plus 3. Great. Now just go for the second one, integration. How we integrate? When you integrate the same one in yellow here, x squared plus 3x plus 7, we integrate it. We integrate x squared will be x power 3 over 3. All right, x3 over 3, it means 1 over 3 is equal to 0.333. The differentiation of 3x, 3 is a constant, and x will be x squared over 2, so with 3 over 2, which is 1.5 x squared. Integration of 7 is equal to 7x. So y equal, I expect to be poly, what? The differentiation, I use derivative, der, integration, I expect end, integration, so poly end. Let me just check if I still remember this one, P1. Yeah, that's right. That's the coefficient, that's right. That's exactly what we got here. That's exactly the same. That's 0.33x power 3, 1.5x squared, 7x, and no constant term, because the last here is 7x. If you want to have constant term, you can just add 0. So not equal, add 0. That will be the result, right? So now we did most of the mathematical operation, addition, subtraction, multiplication, division, differentiation, integration, and polynomial. You need it in many problems. Just you can now avoid your calculator. Just do it. It's very fast. Once you put your equation with polynomial, you can do most of the mathematical operation that you need to solve your problems in science or math course. All right. Now we'll go for something really important in your application. When you go to the lab and you get some points, you get the data and you try to plot the data. So you need to get the best fit curve. Sometimes you need to fit a straight line or quadratic equation, whatever that you want to fit the curve. So let's just make this one big. So you have here in some experiment you did in the lab, x represent the independent variable that you are controlling. For example, if x represent time, so in 1 second, 2 seconds, 3 seconds, and let's say y, you are measuring the current, electric current. So maybe at 1 second you measure 10 amp, after 2 seconds you got 11 amp, and so on. So you want to sketch or plot the relationship between y versus x. All right, so you can locate points. There is no problem about that. You can locate points, but to connect these points, how you connect these points? All right, so maybe if you have idea when you sketch it, you put the point, Then you say, okay, maybe you are asked to find the best quadratic equation. For example, if you are doing Ohm's law, you find the relationship between the current and the voltage. You expect straight line, so you can get the best fit, the best straight line that fit the data that you have, instead by doing manually trying to adjust the line between the dots. All right. So in this example that you got the data from lab, and I want to do the best polynomial, the best second order equation, the best quadratic equation to fit into one. So how you do that? Let me now show you how to write the program. Of course, the first thing you got to enter to MATLAB x and y. How many elements do you have? We have 1, 2, 3, 4, 5, 6. All right. So we'll go to MATLAB. Just let's minimize this back again, and I'll go to let's just erase this one. Maybe I will need to the data I have here, x is equal, I enter the x's. So x equal, and you can enter it element by element, 1, 2, 3, 4, 5, 6, 7. No, I'll have only up to 7. That's what you have here in this. You just make it bigger here. See, x from 1 to 6, not to 7, all right? And you have 10, 11, 12. Let me just type. So I type from x from 1 to 6, and the output from the experiment y as the value 10 space 11, 21 space 2, 3, 7. So I just type the result of my experiment, x and y. So what next? I want to find the best fit, the best curve that will fit the data. So I will write polyfit, but I want to call it name. I want to call this one name. So let me call this y1. All right, y1. And I will write the output y from the poly fit. So what's polyfit? Polyfit, it means that it will find the coefficient of the best polynomial that fit this data. So let me call it P. So this will be the polynomial. So what's P? I just choose, you can choose Y as I did in the beginning, but just I want to remember, because when I will when I try to review the program in the future, so I can remember. So P, it will give me the polynomial. It will give me the coefficient of the polynomial that it fits this data. So polyfit, and then you will say that the independent variable of this polyfit x. What does it mean? I'm asking MATLAB to take the x here that I use it in the lab. I want to use MATLAB to use it as input, as independent variable, and then y, and then I'm asking take also y, take my result. So I call it y1 here. No, there's a back y. So I want MATLAB to take x and y in this order, by the way, independent variable first, and then y, the out data, and then the last one. That's your choice. Do you want straight line? Write 1. Do you like to have quadratic? Write 2. So I need to write 2 here because I want to get the best quadratic equation that fits this data. All right. So in this way, I got the polynomial. Let's just forget, I don't want to sketch anything now. Just I want to know what is the polynomial that fits this data. So let's go here. let's just run the program to clear the, okay, it gave me the polynomial here. So the polynomial that I choose to be quadratic, it gives me, that's a polynomial fit. The polyfit function, it took x, it took y, and then 2, I choose it to have the second order. So let me put comment here, 2 for quadratic polynomial. So to make a comment, it has to be percentage here. Okay, that's fine. So it means the equation that will represent this data here, negative 0.3750, which is this number, I got it. That would be x squared. Why I know the x squared, not x cubed? Okay, I'll remind you. You just go from the back here. How many terms you have? 1, 2, 3. Subtract 1, you get 2. So the highest order is 2. That's it. So that's the coefficient of x squared. That's the coefficient of x here. That's the coefficient of x, as you see. And that's the constant term, 11.3. So that will be the best data that you do. Of course, every time you are adding or increasing the number you put here, you are getting more accurate. You can have polynomial of order 3 will be more accurate, order 4 will be more accurate, but you don't have to do that. If you already can plot the point and then you plot what you get from the polyfit, and you'll find they are so close enough for you, that's it. Because you can continue till you get 100 terms, but it's not practical. It's wasting time. All right. If I do, let's just do 3, you will get different polynomial. Anyway, I saved the polynomial here in the answer. That's the polynomial of order 2. And now I choose it to 3. All right. Let me now run the program and write P. Why I'm typing P? Because this is P. All right, so I'll write P to give me the result. So this is the coefficient of order 3. So that will be 1.08 times x bar 3 minus 11.7 x squared, 35.3 x minus 16. And also, anytime you increase, okay, on order 4, then you can get the best polynomial at order 4. And every one, it will give you better accuracy every time you are going to get better accuracy. All right. Obviously, that every time you are increasing the order here, start the coefficient getting smaller. It means it's getting like not really very effective. And I told you the best thing when you sketch it and you sketch the points and find how close the points to the best curve that you choose. Just let's make it like 10, for example, 10 terms. That's also another thing, benefit of what is that? Polynomial is not, oh, it didn't. Why? Because if you want to have order 10, you got to have more data. You have only from 1 to 6, you have only 6 elements. And you are asking for order 10. So we did order 2, 3. Let's just go step by step. Now if you do 4. You get, obviously, you see it's getting smaller this time, and but it's more accurate, of course. You get 5. Now we make 6 terms. You can't. So, and just makes sense. Like if you have 1 point. Let's say they have 1 point, and ask the MATLAB to give you the best straight line. How to make the best straight line from 1 point? You can plot infinity of straight line passing by 1 point. So at least you have 2 points. So when you have, if you want a straight line, like x plus 4, all right? So you have here 2 terms, x plus 4. You have a constant term, and you have x power 1, right? So you got to have 2 data. 2 elements of data. You have x equal 2 things. If you want to have quadratic, at least you will have 3 terms. Quadratic, which is order 2. So now I write 6. I want polynomial of order 6, so you get to have 7 elements of data. You don't have 7 data. You have only 6. So that's why the max you get 5, order 5. So now there is a relationship between the order of polynomial you want to fit and the data that you have. So if you are in the lab and you want to have higher order polynomial, you got to get enough data to get accurate curve fitting for the data. That's important. All right. Great. So let's take the last example as an application. And this is a very interesting problem. That's in physics and mechanics. In this one, we have a small rocket, and this rocket is launched from 4 feet pedestal. And this is the 4 feet where you are going to launch the rocket. It's like a toy rocket. And then, as you see, it will go up till it reaches the maximum and then start to fall down and then hit the ground. So at t equals 0, the rocket was here. The height h, we are going to use h to represent the height of the rocket. How far from the ground? 4 feet. And every time h, the height increases till it reach here. Of course, when it's shot like that, the speed starts to decrease due to the gravity. Gravity is pulling the rocket down. So every time it's decreasing the velocity till it reaches the maximum. All right. When it reaches the maximum, the velocity will be equal 0. And the velocity, as you know, it's the first derivative or the differentiation of the height. It gives you the velocity. Distance, how you find the velocity, differentiate the distance. Here the distance is vertical, which we call it height. So if you differentiate the height, make it equal to 0, then you can find the time where it reaches the maximum value. And then if you want to see, or if you don't know the velocity here when it hit the ground, because when it hit the ground there is a velocity for the rocket. So when it hit the ground, it means the height is equal 0, because the distance between the rocket and the ground is equal 0. So if you substitute by h equals 0, then you can find the time that when it will hit the ground. And if you know the time when it hit the ground, then you can find the velocity at the ground. Let's just take it step by step. So that's the application example, which is the last thing we are going to do. So the height was represented as the height of the method represented by this polynomial, -2 t squared plus 7t plus 4. So it's function of time. Well, so to solve this problem, first you have to represent the polynomial. Let's just go there and represent the polynomial. So you write h equal to the polynomial. You have -2 t squared, so will be -2 the first coefficient, second coefficient 7t will be 7, third term is 4, so the constant term is equal to 4. So we represented the polynomial. Well, for this polynomial, let's solve the first question here. How long will it take the rocket to hit the ground? How long? So they want to find the time when it starts to be launched here, which is t equals 0, till it hit the ground. When it hit the ground, we said that h means equal 0 because the distance between the ground and the rocket is equal 0. So how to find the time that when h equals 0? And this is h. So if you make this equal 0 and find the value of the time, it means you are finding the roots. So, okay, we write that time when it hit the ground called tg. So tg, it means the time when it hit the ground. That would be equal the roots of the polynomial, which is called h in this case, right? So it equals the roots. Let's run the program here. So if you now write tg to give you a time. So the solution of this polynomial, t equal 4 or t equal -0.5. And the negative time is rejected, so tg is equal 4. It means it will hit the ground at t equal 4 after 4 seconds. After launching this rocket, it will take 4 seconds to go back to the ground. Great. So we solved the first question. The second one, what's the maximum height it can reach? It means when it reaches, this is the maximum height. So what is this height? The value of the height. We know that it reached the maximum height when the velocity is equal 0 and the velocity equal the first derivative of the distant vertical displacement. So now I want to find dh by dt first and then make it equal to 0. So when I make that, it will give me the time that it will reach the maximum height, right? So now how you find the derivative? Easy. I will call it velocity. What does it mean? It gave me the velocity. It gave me the derivative, right? Poly der, that's the derivative, all right? Of what? Of the polynomial. What's the name of polynomial h? So that will give me the polynomial. Let's just run the program and see if you type v, what you get. When you type v, it means that the velocity, if you like to write the velocity equation for h, it will be equal to negative 4x plus 7. So let me just go ahead and write here. So the velocity, that's function of time, equal to the first coefficient here is equal negative 4, and you have two terms, 2 minus 1 is 1, so the highest order is 1, x power 1. So you have negative 4 times x. Negative 4 times x, that's the first term. The constant term is 7 plus 7. That's what I got from. So this is the equation of the velocity at any time. How I did that? By finding the derivative, by using this derivative of polynomial. The question is, I want to know when it will reach the maximum. It will reach the maximum when the velocity is equal 0, because the velocity started with the highest and then was decreasing due to the gravity till it reached the maximum. At this one will stop just for a very small time and then start to fall down. So I find the roots of v of t. If mathematically we say negative 4x plus 7 equals 0, no, by the way, it's not x. That's a mistake. That's time. The independent variable is time. I'm finding the derivative of this with time. So if you make this equal to 0, you can find the value of t when it reaches the maximum height, or when the velocity is equal 0. So negative 4t plus 7 is equal 0. It means t is equal 7 over 4. 7 over 4, like, okay. So just I will go there and I will see the t, call it tm, meaning it reaches maximum. You want to find the roots. The roots of what? Of which polynomial, h or v? V. I want to find when velocity is equal to 0. That will give me the time when the velocity equals 0. Now just let's run the program. And all right, tm. Okay, it's at 1.75. So it will reach the maximum here at 1.75. At time equal 1.75, the velocity is equal 0 and h is maximum. Now, what is the maximum height? H. So I have to get this value of time that I got, which is equal 1.75. This is the time, and substitute in the equation of the height, h of t. This one, I put t equal to 1.75. How you find the value of h when t equal 1.75? It means evaluate the polynomial at this time. So I use polyval. So I will say h max equal, let me just write in the program so I can keep it in the program here. I can keep it inside the code here. H max equal what? Polyval. I'm evaluating which polynomial? H. I want to find h max. At what value of t? At tm. Because I have now tm, I have two times. I have tm, I have tg. No. tm, that's corresponding for the maximum height. Now, MATLAB will take the time tm, substitute in the polynomial h, which is the height, and get me the maximum height. Let's just run the program, but just with the semicolon, not to print all the thing. And then I write h max. It's 10.125 feet. Far from the ground, by the way, because this h equation, it's measured from the ground. If you want to calculate the maximum height far from the base here, you subtract 4. That's no problem. Anyway, not to take a long time, we are done with B. When it will reach the maximum height, we did it. We'll find the maximum height, we'll finish. The last one is easy. What is the velocity of the rocket before hit the ground? I mean, you want the velocity of the rocket here when h equals 0. We already solved this one. H equals 0 when we find the roots of the equation h, we found tg. Tg, the corresponding the time when hit the ground. So I take this time, I substitute in the equation of the velocity to find the value of the velocity. This one, this is the velocity. So I use the time when it hit the ground and substitute in the velocity. So I will say the velocity when hit the ground, Vg, is equal the polyval, and now I want to find evaluate which polynomial, h or v, because I want to find the value of the velocity at what time when it hit the ground, at tg. I run the program here. So Vg, that's equal to -9 and 9. Of course, negative value is rejected. So we'll say that the rocket, when it hit the ground, it will hit the ground at velocity equal to 9 feet per second. By solving this application example, the last one that used in physics and in mechanical engineering, we are done with this session, and I hope that that was useful. And remember that I didn't type the output in the nice format because just to save the time. But if you go back to other tutorial session, I showed you how to type the output with good format, readable format. Okay, thank you, and till you see you then, have a great